Hi, my name is Steve, and this talk is about modeling all the things using D. D is known for its superb power in metaprogramming, but there are complex, confusing, and downright ugly ways to write generative and modeling code, and there are also a lot of pretty ways to do it. And this will be a bit of a showcase of some of the tricks and concepts that I've seen and used when writing lots of D code over the years. So let's talk about the modeling power of D, right? D starts with interfaces and classes. So an interface is a model for an actual concrete type, and the class is the concrete type. Then we have introspection. So introspection is another tool you can use to look at models and figure out, let's say you want to do something custom, and included in that is user-defined attributes. So user-defined attribute is a mechanism that you can use to attach specific metadata to a model or a type. And you can use that with your implementation to kind of customize how that implementation should work. And of course, we have generative models. So these are models that you use to build more things. You don't use the models directly. You build things using those models. And of course, one of my favorite items that D can do is opt dispatch, which allows you to hook any calls that don't already exist. So let's look at the original modeling system. The original modeling system is the interface. If we look at this little code example here, we have an animal, and it must implement a function called speak, returns void, it takes no parameters. Okay, so then we implement a dog, that's an animal, and its speak function says woof. And of course, this code all works just fine. The compiler provides this way to model how an API for type should look. So in other words, the compiler's enforcing everything here. The compiler tells you, yep, you implemented the speak and you did it right. Otherwise, you get an error. But it's very rigid. So let's say we wanted to make a smart dog, which we can tell it to speak n number of times, but it has a default value of 1. So if you call it without any parameters, which technically fits the interface, it should just speak once, and that works. However, the decompiler is going to complain about this because the specific function speak must have no parameters. It can't even have a parameter that has a default value. So we also have the problem where members cannot be optional. So if you put a function in the animal, you can't say, well, you can implement this function sometimes and maybe not other times. That's not possible. There's no field members you can require in your interface. And of course, there's no types or enums or compile type API members that you can say, we have to have some type in there named this. So those pieces are definitely not available for an interface. So that leaves us to duck typing. So duck typing comes from the saying, if it walks like a duck and quacks like a duck, well, it's probably a duck. And basically what you're saying here is this animal that comes in, just the act of using it that way defines that it must provide that functionality. So in this train animal function, we can see that we need the function speak. Now, we could create another function that takes an animal and do something different with it. It would require it there, but we wouldn't require the speak. So it's like, what is an animal? It's less rigid about the API, but it's not really defined. So there's no definition that says, this is what an animal should do. And there's nothing to look at. It's just, can you call this function? Yeah, sure. Okay. But we can add a template constraint. And a template constraint can be used to define the interface. So you can kind of take this template constraint and say, okay, well, I can see from the template constraint that the animal must be able to call the function speak with no parameters. Now this works, like it works for smart dog, and it can work for other things. So this is kind of a less restrictive way to do interfaces. However, they're nebulous and repetitive. You can see that basically I don't have a type to look at that says this is what an animal is. I have to kind of understand from the template constraints, which might be spread over different functions, to find out, does it actually fit this model? And it's also kind of a little bit repetitive here because every time you say, I want to call a function on an animal and I want it to be able to speak, you need to repeat this template constraint, and it's also repeating the actual implementation of the function, which is a little bit annoying. So that leads us to a little library I wrote called Strawman Structs. Now, those of you who have seen my talk on Strawman Structs, I don't know, 6 or 7 years ago, that basically is what I implemented. I never implemented it back then, but I just did it for this talk. And what it is you're using a struct to model what another aggregate should contain. You replace the complex constraint with a self-documenting model. In other words, you have something you can point at and say, that's the strawman. That's the thing that tells me what it should happen. Now, to start off with, we got to understand that introspection is key here. We got to be able to introspect this strawman to determine, what does it do? We can only introspect a concrete type, so we can't introspect a template. We need to have something that's like a template parameter. And for that case, I added this little hook called anyType, which can be any type, unless you give it a list of types that it could be, and it has to be one of those types. And it has a tag on it, right? So the tag is used to determine, like, let's say you use any type in multiple functions, they all have to match. So it's a way where you can associate, well, it can be any type, but they have to match in these different spots. You'll see that later. Now we also have a self type to refer to the actual type being tested. You could use the type itself, and that also works. But, and again, the Strawman Struct is not something you're actually going to use for implementation. It's just used as a model. So using self makes it a little bit easier to deal with on the introspection side. And finally, inheritance by defining what types it's also like. So if you already have a Strawman Struct and you say, okay, well, I wanted another Strawman Struct that's like that one, but adds these other features, that's where that is also comes in. You can see from this example, which is actually in the Strawman Struct repository, how this can work. So on the left, you see is input range, is forward range, is bidirectional range, and is random access range, all from Phobos. Now, that is a model, okay? That is saying it can do this, it can do that, these are the requirements. But you kind of have to construct that model in your head from the list of constraints that are listed there, right? So I kind of look at it like if you went down to your local records office and looked up your property deed, you would find that it says, okay, start at this location, walk north-northeast at this, direction for so many paces, and then, or so many feet, and then that's another corner of the property, and then you turn this many degrees. And I mean, there's literally a description of how you would reconstruct the drawing or model of your property. That's not that easy to read or understand, and it maybe takes an expert to understand it. Here we don't need to be complete experts. We can kind of see what's going on here. But it's not as clear at all as the right side. Now, the right side is just basically says, okay, instead of is input range R being, okay, the return type of empty has to be bool, I just define the function empty with a bool, and the Strawman Struct library is going to construct basically what's on the left from what's on the right. So the code can be really messy underneath. That's okay. It doesn't matter. You see the model's nice and pretty. The model is fully understandable and doesn't have all those little messy details that you have to deal with. Those are all dealt with by the introspection. So forward range model, you see use of the self type, and you also see the use of the is also inheritance system, which says, okay, it's also like the input range model, but I'm going to add the save piece to it. And bidirectional model, you can see where I reuse the element tag. So basically I'm saying I'm going to add a function called back. It has to implement that function, and the type that comes from that back must match the type that I specified in the front. So that's actually checked, and you can see that same thing on the bidirectional range from Phobos. It says is return type R back, and it checks if it's the element type. Now, element type is another introspection thing, but we don't need that here. We just name it. And the random access range is not completely implementing exactly the same thing as the Phobos version, because I don't have anything yet in Strawman that would allow you to say this whole section of API might be optional compared to this other section of API, which you would need for that. But I mean, this is not a real library that I would, at this moment, recommend anyone uses. It's just a kind of a toy project to demonstrate what's possible. So let's move on to the next modeling stuff that we're going to look at, and that's getopt. So getopt actually uses modeling. If you're unfamiliar with getopt, what it is a function that allows you to parse the command line arguments of your program and put the values from those command line arguments into variables. So here we have verbose, age, and name. That's the data that's coming out of or is getting deserialized from the command line arguments. And to put those in there, we specify a model of, oh, if you see the option for verbose, put it in verbose. If you see the option for age, put it in age, etc., etc. And we use introspection to say, oh, it's an int, it's a bool, so I can parse true or false or whatever it is. So that is all handled by it. But there's some problems here, right? First of all, you got to repeat the names 3 times. So you see verbose, age, and name repeated 3 times. First to define the variables, then to specify the option name, and then to specify, link that to the actual variable. So that's kind of annoying. We also see the structure is split between the getopt call and the declaration. So first we're declaring this thing, this model, but with no specification of which things are actually options. The mapping of the options to the values actually gets done in the getopt call. Now keep in mind, these could be far away, right? Verbose, age, name could be defined anywhere. It doesn't really matter. So having that all spread apart and having to follow, okay, where does this stuff go? That's a problem. And finally, the parameter order is library enforced. So you notice this config.required in there. What that says is that the name argument is required. You can't run the program unless you have specified the name argument, and that's enforced by getopt. However, there's no real requirement to have that config flag attribute to the following option. That's all defined by the getopt function. You have to read the documentation to understand that. If we look at getopt, it's essentially a DSL describing how to populate the data from the command line parameters. Okay? We have command line parameters, those are strings, and we have variables, those are values, and there's getopt just connects them together. Now, if that's just name to variable to store, right? If only there was something, if only there was some structure that would have variable names assigned to values. Oh yeah, that's right. We do have that. It's called a struct. So instead of using the model that you built based on function calls, let's build the actual model, right? The actual model is easy to understand. Here I have a struct options, which has verbose, age, and name all in there. I declare an instance of it, and then I call this function getopt2, which is another little toy library I wrote. This one I might actually publish because it's kind of neat. It was very small, easy to write. But I pass in the options, and that's it. All it does is it constructs a call to getopt based on introspecting that stuff. I don't have to repeat myself, right? So there's no there's no requirement to say verbose 3 times or age 3 times or name 3 times or even 2 times. It's there, right? And so also the compiler parses and validates the structure for me. So it'll tell me, I don't have to ask, did I make the syntax right? Where you would have to, like in getopt, if you put those configuration options in between certain things, it'll complain. We're waiting for the library to do that, and sometimes the error messages aren't great. Here, the compiler is going to not compile. Like it's going to say, oh, you missed a semicolon, or you put this UDA on things that it shouldn't be on, or you put it in the wrong spot. So I'm using the compiler to help me. Plus, UDAs are better than interspersed config parameters, right? So I can use a UDA on an individual field. I can use it on all the fields. I can use it on a subset of the fields using the colon syntax or the brace syntax. All that is available when you use UDAs. And one of the things I wanted to show here is this technique that I think a lot of people use, but in case you aren't aware of it, is using introspection blueprints. So basically, we take a thing, and out of that, we use compile time, take those attributes, all the things that you can figure out about this, and put it into a structure that I can later use to do generative code, right? So instead of having to loop, this is like in replacement to has UDA or get UDA. It's much easier to just have this struct. You generate it once. It's a lot less compile time. We're taxing on the compiler to generate the struct once, and then you can use it multiple times. And let's do a comparison between RDMD. So RDMD is a program, a tool that D ships with that allows you to compile your code with one call. It caches the binary. It kind of acts like a script. Now, RDMD is a big user of getopt. So this is the current code and we're going to look at some of the issues here. So first of all, we have some options in module namespace. The chatty, build only, try, run, force. All those things are in module namespace. And in fact, in the real code, they're far away from the main function. So when you see the call to getopt and you're saying, okay, well, where is this defined? It's not anywhere obvious. It's somewhere else. So again, the definition of the options is spread out all over the program. There's comments here to help link options to variables. Well, this is kind of silly, right? So basically we're saying in the comment, oh, this -o function, matches the -o option. Well, we don't have to do that with getopt2 because it's already there, right? Everything's all in one spot. Much repetition of names throughout. So you see add stub main is -main, and then of course down here we see -main links to add stub main. We're repeating a lot of the variables over and over again. You have compiler to address of compiler, lots of repetition. Okay, now let's compare to the getopt2 version. Now we have all options in one place, which is kind of a benefit and kind of a drawback, because actually we're going to have to copy some pieces to the global namespace because there's a reason they were up there. They're needed in different places. Now I might actually rewrite RDMD a little bit in order to make this less painful. Now there's a lot less manual linking of options to names and variables. To be honest, I would take some of these. I did for the O function. So you see O, that's only used for that one function. Instead of calling it -o, I just called it O, and now I don't have to specify the real name. There's other things here, like I would probably take exclude or exclusions and change it to exclude, so I don't have to put the op name, things like that. Another benefit is it gives me one place to deal with option processing. I don't have to look all over the file. I don't have to look all over the program. I just look in this one spot and I know, okay, this is where all the options are processed. That's a nice thing when you're going to do maintenance on a program. And finally, the pass-through option is now passed on the function call, not in the struct itself. And the reason that is because some options apply to the whole thing. So this is another thing, like you might not realize this, but you can specify the pass-through option anywhere in the getopt command line. So not anywhere. In some places it will complain, but in other places it won't. But it's still going to just apply to the whole thing, right? So this is just, it's not that it's a problem, but it prevents you from writing stuff that is really confusing, in our DSL. So it's a lot of times in DSL we don't want to worry about all the little syntax details. We just let a lot of things happen. Whereas, if we use a model, then we're kind of making sure that the person who's writing the model is doing a good job. So that's getopt. Now we're going to move on to another type of model. It's going kind of fast, but I only have 30 minutes for this. So we're talking about generating with models. So take in Strawman Structs, we kind of had a model that all it did was exist as a model, and we used it to look at other things. Well, now we're going to use a similar thing to say, I'm actually going to generate the code for this, right? I'm not checking to see if something matches. I'm actually generating the new thing. And this kind of starts with white hole and black hole, which were added in 2010. And it's implemented with auto implement. Auto implement is just basically the thing that takes an interface or class and looks at all the abstract functions and implements those functions in a derived class. Okay, it takes a template, and that template returns a string that's then mixed in. So the template is given the function that it wants you to implement. You take that, you return a string, and that's spit out as the implementation for that function. There are lots of quirks and stuff with it, but it's pretty old. So, but you can see here I have my interface animal from earlier slide, and I create a silent animal, which is a black hole, which basically means swallow all the functions. Any function call just doesn't do anything. And there's broken animal, which doesn't swallow all the functions. It just throws an exception if you call that function. And those have their uses. But this is generating with interfaces. But of course, you're using an existing model to implementation that matches or mimics that model. But for interface classes, the entire model must match. Like there's no optional things. There's no UDAs you could say, oh, well, don't do this one. No, it's going to require, because the compiler says this class has to implement this interface, it's going to require that method exists. So we move on to a better option for this, and that's opt_dispatch, user-guided model generation. This was actually added earlier, but I don't think it's really come into great use until more recently. Opt_dispatch basically takes any symbol that you give to it on a type and passes that symbol name into a string, a template parameter string. Now, you can do anything you want with that, and it's only going to happen, you can still use constraints and things like that to determine whether you want to use it or not. And this is kind of an example. If you look up swizzling, you can see what that's for. It's basically changing around which fields go where, so you can swap the X and the Y, or in this case I'm doing W twice. This was an example I saw on Wikipedia. Like auto implement, it's like auto implement, but it uses actual calls to determine which methods need implementing. So with auto implement, we had to implement all the abstract functions, and we didn't have any extra ones we could implement. Notice that this one, I only call opt_dispatch once, so I only have to implement one function. So it's like a sparse implementation. The possibility is there if you use it, but it doesn't need to be there. Like you don't have to generate every possible swizzle that could possibly happen here. So that leads us to a project that I've been working on for a few years now called sqlbuilder. And I want to highlight a piece of sqlbuilder in here. First, I have to tell you about kind of what it is. It's a library that allows you to build SQL queries, as you would expect, and also does the deserialization of those rows that come back from the database into the actual types that they are. So we get two pieces here. First, we want to define our model that represents the rows in the database. We use UDAs to describe SQL-specific information like primary key, auto increment, if you wanted to change the type of something or the name of something. And then you can use serialization using introspection to actually fill in those pieces as you get the rows back. You can also, as you can see on the bottom here, use the model to create the tables in the database. So this allows for things like migrations or whatever you want to do. So basically you're kind of abstracted from what the SQL is supposed to be doing. But that's not all we want to do. We also want to do queries, and inevitably queries on databases involve joins. And how the data is related is another thing we can model. So we're going to model relationships using UDAs and a special type called relation. So the relation is actually an empty struct. It doesn't do anything, but it's kind of a token that says, oh, this is a relation to another thing. Now you notice the relation on the top is called books. An author can have any number of books, and we have a refers to the book type, right? And then inside books, we have a refers to author, but that's a UDA applied to author ID, right? So this allows adding constraints to the database if desired. There's actually a function I could say, okay, implement the constraints. But we're also giving names for relationships that aren't, it's not in the model originally or the database, right? So when I say, let me ask for all the books that an author wrote, I have an actual field that's called books. When I ask for the author of a book, well, I don't have a field, I have this UDA. But you'll see in a minute that we're going to use this model to implement how that works. So the dataset type in sqlbuilder is actually a generated struct with opt_dispatch. And all it does is if you ask for a field, instead of giving you back that field, instead of you giving back a string first name, which obviously that's not useful for querying, it gives you back a column definition for first name. And it tells you which table it's in, all the joins that would be needed to get to that table. And also, if you ask for a whole struct, it knows how to do that as well. So you can see at the bottom here, we have a data set based on author, and we have select DS, which is the data set, and all the books from that data set, where the book type is reference. So that param thing is kind of a clunky part of it, but that's really to prevent SQL injection, because we're going to use, anytime you see a param, it's going to use a prepared statement and substitute variable in for that. Now, instead of fields or functions, like I said, we're using opt dispatch for all methods. So there's just an opt dispatch. That's it. The model gets mapped to column definitions, as I said, and relations get mapped to a new data set that understands how to join that data set to the original one. Nullable columns automatically determined based on join. So if you have a left join, your join might be null. Like you could possibly have an author that doesn't have any books, or a book that doesn't have any reviews, right? So that's a possibility here. Oh, and by the way, you might notice in the where clause, it's a little bit clunky where you have this commas and quotes, but this is actually designed for string interpolation. If we ever get string interpolation, that would be a really nice thing, and I would happily replace that syntax with string interpolation. Now, I just want to show you a little bit about the dataset implementation. It's really straightforward. It's about 70 lines of code, give or take. There's a lot of comments in there and some other stuff. But it's basically split into two opt dispatch calls. One for fields, that is field says, oh, if I introspect that row, is that a field name? And then one that says, is it a relation name? And we can nest as much as needed. So I can go author.books.author.books, and it will know, okay, I'm going to add all those joins to get to that piece. And we can do those queries based on that without having to worry about constructing an actual SQL statement. That's one thing I don't like about SQL is you say what you want at the front, but how you want it is somewhere later. So this allows you to construct them without having to worry about that piece. And this is an actual example from my code. Yes, payroll man still lives. This is getting some commission payments information. And that where or spec is a little ugly, but what it is it's saying anytime you add a new where, it's going to be anded on to the last one. And an or spec is saying, no, actually do or and not and. So here I'm saying, give me all the plan periods, which is a thing that says how many commissions have been paid for that plan period, the plan itself, and the person from that plan. And I just get those back directly from the database. It figures out how to serialize that for me. And I only want to see it where the amount paid is different than the amount payable, or the potential for payment is different than the amount payable. And then we have ordering, same thing, DS, plan, person, last name, all those are data sets until the last name is actually a column definition. And same thing with person ID, and then you have the descend function, which can tack on a descend to the. So this is all stuff like I'm writing SQL here. I could use strings. I mean, there's strings involved in this, but this is much nicer, and I can build it out of order. It's just a really neat little library, and I do want to publish that at some point soon, but I need to work on the documentation for it. And the final thing I wanted to talk about is a possible new feature that I would like to see in D called struct lambdas. So D structs need to be declared first. This is an example, the example from getopt 2 earlier. I first had to specify a struct options. Then I had to declare an options instance, and then I called getopt2 on that options. Well, that's, again, repeating myself. This is the only reason this struct exists, is to call the options function. I wish I didn't have to do all that, but I do. And that's just the way it is in D. You can't define structs in line. However, look at C. C can actually do this. You notice this offset of call is given a struct without any name, without any type test or anything. It's just an inline struct. And it says, tell me the offset of Y in that struct, and it works. because it's not exactly an expression, but it can be a type that's not a declaration, or that continues a declaration, right? But of course, we're in C, so it's of limited utility. Like, this is probably one of the only ways you can do that. And C should not be able to beat D here. That's my opinion. All right, we should not be playing second fiddle to any meta programming that C can do. We should be able to do this. Now, D struct lambda, so if I did this with D, this is kind of how I would write it, but it can't use the same syntax because struct definitions end the declaration at the closing brace. That y.offset would be a new statement, even if the grammar, like the grammar doesn't allow you to just put a struct in the middle of an expression. But even if it did allow it, it would be ambiguous. Like, what is that .y.offset? That really should be referring to, some global y, and offset of, I don't know what that would mean outside of the definition of a struct. But like I said, we can't do that. However, functions use a dedicated syntax. We could invent a syntax for inline struct definition, or we could just allow this possible change, where you could say, anytime I'm taking a type in a template, allow you just to define an inline struct there. That wouldn't hurt, right? I mean, you could do that. We kind of have the new class syntax where you can define a new class anonymously. We could do something similar with structs. I would like to see some options or proposals for this, because I think it would be nice. So here you have my GitHub 2 example, but instead of specifying the struct externally, I just specified in line. That would be really cool to be able to do that. So in conclusion, for this model talk, using models to tell the compiler the thing you were talking about also makes it easier for users to understand. If I can point to a struct or a class and say, that's the thing that I'm talking about, instead of having to describe, oh, it takes this function and it does this thing, or follows this constraint, it's much easier to just point at that thing, and the compiler is already set up to deal with that. The real code can be messy, right? All the real code that you can click on the links, or not click on the links, but you can visit the links that I put on my talk, and you can see how the code works, and it's not always pretty, But that's okay, because the user doesn't see that. They just see the model and the usage. The implementation can be messy. If you find yourself implementing a model system manually, stop. D already has modeling systems, structs, classes, interfaces. Use the modeling system that the compiler gives you. It's actually really, really nice. And there's no reason to avoid having the compiler check all this stuff for you, right? So, for instance, the GitOpt thing. And finally, use all the tools to make models easy to configure and understand. And those tools are introspection, user-defined attributes, and opt dispatch, one of my favorite things. And I want to thank WebFreak for this awesome graphic. And that is the end of my talk. Go out and model some stuff. Thank you.